Welcome everybody to session DAT402, using performance insights to optimize database performance. My name is Kyle Haley and I'm the principal product manager for RDS Performance Insights. And a little bit about my background. I've spent the past 25 years or so working on database performance. I've worked on many of the industry-leading tools on database performance, and this is by far the most exciting project I've been on. The scale and rate of growth at Amazon's amazing. And it presents some unique challenges. In the past, I've worked at Oracle. I redesigned the performance pages in Enterprise Manager. Show of hands, how many people have used Enterprise Manager? A lot of people. Okay, cool. I also worked at Quest. I worked on Spotlight and Foglight. Anybody use Foglight or Spotlight in the past? A few people. And then I went to a company called Embarcadero and led the design of a tool called DB Optimizer. Anybody use DB Optimizer? Oh, cool. That's my favorite little tool, but other things I've been known for is I wrote code that actually reads the memory of a database, so we don't have to run SQL. And the reason I did this is when it comes to performance monitoring, one of the tenets that we have in our group right now, Performance Insights, is to have the least impact on the database as possible. And by reading memory, it's the cheapest thing you can do on a computer. So if we can bypass SQL and read the performance stats directly out of memory, we have almost no impact on the database. And now I'm super excited to be at Amazon, where I can take all this experience that I've done on different databases in the past and do it on all these new databases, MySQL, Postgres, Aurora MySQL, Aurora Postgres, as well as Oracle and SQL Server. And as I said, the scale and rate of growth of RDS is amazing. And probably the most impressive thing about this project that I've seen is the scalability of Performance Insights. The bulk of this talk is really how to use Performance Insight. I don't talk too much about the infrastructure. But we've built an infrastructure that will scale to millions of databases. And typically, when one uses a performance monitoring tool, one installs it either on the database machine that they have the database they want to monitor, or we set up a secondary machine, install some software that connects to the databases we want to monitor. And that can be a lot of work. I don't know if any of you Oracle Enterprise Manager users have ever had it broke, but it's broken on me, and it can be really complex to try to get it working. And if we want to do something like cloud control, where we're going to monitor several databases, we have to install cloud control on another machine and connect it to all the databases we want to monitor and manage it. With Performance Insights, we've eliminated all that. We've eliminated all the headache, all the administration. It's incredibly simple. When I create a database in the wizard in RDS, there's a checkbox that's checked by default. You could uncheck it if you want. I wouldn't recommend it. So it's on by default. That's it. That's all you do. There's no management involved. You don't have to worry about how much space it takes up, any overhead. We have a very lightweight process that runs on your database host, reads the memory, sends the data off the host into native AWS infrastructure, and we manage it all. And it's scalable and rapid. So between the time we collect the data on your database and the time you visualize it in the dashboard, it's typically around the second. We'll do some live demos, and you'll be able to see the effect. So what's in the agenda for today? First, we'll talk about what is Performance Insights, and then we'll talk about how we collect data. We collect data in a unique way called sampling. It's a bit different from a lot of tools that use time series statistics, using counters in the OS or in the database. And we roll the sample data up into something called average active sessions. And this is our core metric in the interface, and it measures database load. So I'll explain what is average active sessions and what is database load. And then we'll go into some real-life use cases, some examples in the slides, and then we'll look at exploring the Performance Insights interface by some other dimensions. And finally, we'll do a live demo. So what is Performance Insights? In RDS, we've gotten a lot of great feedback from customers. You know, they love the automated patching, the automated backups, the different availability zones, the HA infrastructure. But one thing they've been asking for is visibility into the performance of their cloud database workloads. And on databases like MySQL and Postgres in particular, I find there's not a really rich ecosystem of tools to monitor. People often have scripts, or they trace, or they look at log files. And it can be an onerous process to figure out what the performance is on a database and where load's coming from. So one of our goals is to create an easy tool. And also, we have a huge a huge set of customers from small to large. And especially on the smaller end, some customers don't even have a DBA, or they might have a part-time DBA. So the tool has to be easy that anybody can use. And they also want a single location. I want one place to go to and see immediately what's happening on the database. So our first step was a couple of years ago in 2016, we released something called Enhanced Monitoring. And this is a little bit different than CloudWatch. And the differences are, first it's targeted at RDS hosts. It's OS-centric. It's not database-centric. It's OS-centric. It tells you about the operating system your database is running on. One of the cool things is it has a process list. So in RDS, you can't shell into the host you're on. You have to get it all through the console. So in the console, we can see the process list. So it's like top on Unix. I can see the top processes by memory or the top processes by CPU. And another cool thing, the differentiator 2 years ago from CloudWatch is we could collect metrics down to 1 second granularity. CloudWatch has since announced that as well. One thing I want to point out is, so these are time series metrics. If you look in the top right, there's a bunch of charts. And a couple of problems with this is, one, it can be challenging to know what to look at. What values are good or bad? How do I correlate these graphs? I personally find it a bit overwhelming and confusing. And so one of the goals is how do we simplify that? And these are also time series metrics. So time series metrics is like, how many page ins do I do on my operating system? Or what is my CPU utilization at each point in time? And these are just one metric. And I can maybe see my page ins coming up. So that means I'm reading data off disk that I'd already written out. And that's going to slow my processes down. Well, where's that coming from? I need to correlate that. So these are single metrics. They don't correlate. And we're going to talk about sampling, which is a different way. It's multidimensional, and we can answer those questions. So introducing performance insights. This is database-centric. All these stats, all the data we're going to be showing is all about the database. So as opposed to enhanced monitoring, where I might see a problem on the operating system but not know where the problem's coming from in the database, here we'll see exactly what's happening in the database. It's a dashboard. The main thing we show is database load. We'll go into this presentation at what is database load. The time frame is adjustable. When you come into the dashboard, by default, it's 1 hour. But you can zoom down into per second samples, where we actually collect data per second. Or you could zoom out to multiple years if you have that much data. We can filter by different attributes, such as what are the SQL putting load on the database, which users are putting load on the database, where am I spending my time on my database? Am I runnable on CPU, or am I waiting for locks? Am I waiting for I/O? Am I waiting for some other resource? And then we show clearly which SQL are causing the high load on the database. Now, the delivery of performance insights has been phased. We've already released on both Aurora Postgres and Aurora MySQL. We've released on RDS for MySQL and RDS Postgres, and we just recently released on RDS Oracle. The next to be released will be SQL Server. I'm actually using it in-house. The code's done. It's just a matter of deploying it to the fleet. And the final one will be MariaDB. And one of our tenets or goals with this interface was to have a guided experience of looking at database performance. We want users to explore the interface, and by exploring the interface, they learn about databases. So the interface is both for beginners and experts. It's a beginner interface. It's easy. It encourages exploration, but also the data is powerful. So it's the exact kind of data that an expert user would want to see. So the big question, what is this thing we're talking about, database load? Well, let's talk about where we get it from. All these database engines have a structure that tells us who's connected to the database. What are the connections to the database? And for each of those connections, it'll tell us which ones are active and which ones are idle. And what we do in Performance Insights is we look at that structure once a second. Now, that might sound like a lot of work, but remember, we're just reading from memory. It's super lightweight. In the tests I've done, my test is less than 1% of 1 vCPU. And what we do is we look at the structure, we ignore the idle connections, and we collect the data from the active connections. So if a connection is active, we get what SQL is the user running, who is the user, what state are they on? Are they runnable on CPU, or are they waiting for some resource like I/O or a lock or buffer access? What host is the SQL being sent from? Like application servers, so I can see the load by application servers. And who's the user running the SQL? And then we expose this as a metric called average active sessions, which is really a measurement of the concurrency of load on the database. How many users are concurrently active in the database? And we call this AAS, or average active sessions. So here's the dashboard. We'll go into this in more detail as the presentation goes on. But basically, it's divided into two parts. On top, we see the load on the database over time. And the idea is to make it really visually impactful and so that we can see any problems immediately. What I see here is there's two spikes. I see a green spike and I see this red spike. We'll go into this more detail. Green is users running on CPU and red's, in this case, locking. And then below that, we have the top SQL. Where is this load coming from? So for like the CPU, that first SQL statement is the one that's demanding all the CPU in this case. So we'll go into this in more detail. Now, I want to talk a little bit about how we collect the data and how we aggregate and visualize it. It'll help understand what's going on. One thing that almost always drives engineers a little bit crazy when I first introduced this is we're sampling every second. So what we do is we come in and say, who's active right now? Then we go to sleep for a second, and then we wake up and say, who's active now? In between, could be a bunch of activity. We don't collect it. It's missing. And that can be very unnerving for some engineers. But what we found is that collecting once a second describes database activity very well. And one analogy is in films. When I go to the cinema, we're actually seeing 24 frames a second, but it is completely coherent to me. It's seamless. I don't see anything missing. And if you wanted to collect everything, just to talk about that for a minute, some people try to, but to collect everything, you'd have to trace. And tracing all the processes on the database would be a massive amount of data. You'd be overwhelmed by the data. It'd slow your system down, and it'd be hard to go through that data and figure out what's happening. So it's not scalable. And also, by the way we collect data, this multi-dimensional data, we'll be able to answer a lot of questions, and we'll see how we answer those questions in this presentation. So here's a visualization of what we're doing. So time's running from left to right. The vertical black lines are every second when we collect data. We wake up to collect the data. The three horizontal lines are 3 users. And then the blue rectangles are active SQLs in the database. So what do I mean by active? A user sends in a query. It takes a certain amount of time for the database to process that query and then finish it. That's the activity time. And now I have 3 different types of queries in this slide. The bottom queries is long-running queries, not run much, it's run twice here, but it's multi-second. And anything that's over a second will always capture it. Above that is a shorter query, a sub-second query that's run fairly often. So we're going to miss sub-second, so we're going to miss it some of the time. But a lot of the time we'll catch it, so it'll show up in our data. Now the top query is a fast query that's not run very often. Odds are we'll miss it completely. That might sound unnerving, but first of all, that query is fast. It's already optimized, and it's not run very often. It's not putting much load on my database. So when I'm looking at database performance, it doesn't matter. One of the fringe benefits of sampling is it filters out all of that noise and helps us concentrate on the big problems. So here I've just zoomed in on one user. And typically we have something like an application server that's maybe feeding out web pages to an end user. And once in a while, the application server has to go to the database to get some data from the database. Or if the user's buying products, we have to put that data in the database, put the transactional information in the database. But a lot of times that connection's idle, but then the application server will send in a query. It'll take a certain amount of time to process it. That's when the connection's active, and then return the result set. Now, if we look at multiple users, visually, this is what the activity might look like. And already we're seeing sort of a visualization of the load going up and down on the database. And this is basically what we're doing in Performance Insights, basically stacking that concurrency. So you stack those users, and then we have a graph of what's the load like on the database. When is the database idle? When is there a high level of concurrency? Now, the next few slides, I want to show that different combinations of activity on the database can look the same in Performance Insights. So in this case, there's just one user. They're running a long query. We sample every second. We find them each time. And in the graph, the Performance Insights graph at the bottom, we'll see one user active. Now, I could actually have a different scenario that looks exactly the same in the load graph. I could have one user run a 5-second query, finish, and another user run a 5-second query. But in the load graph, over that time span, there's one user active during that time span. Now, I don't know how long the queries are running. They might be running shorter queries, maybe 1-second queries. User 1 runs a 1-second query, then user 2, and it goes back and forth. It's going to look the same in the load chart. the activity on the database is a constant one user in this particular scenario. Now, I don't know in what order they're running the queries. In the previous slide, they were running it alternating. Here, they might be running it at the same time. And also, I've done something different in this graph. So the previous graphs were showing the active sessions at a point in time. What we show in the Performance Insights dashboard by default are averages. Each point in the Performance Insights dashboard by default is 60 seconds. So what we do is we collect all the points of activity in 60 seconds, and we divide by 60. That's the average number of active sessions. So I've made it a little bit easier here. What I've done is the point in the graph represents 10 seconds. So I have a 10-second timeline. I find 10 points of activity. 10 divided by 10 is one average active session. Now, I could have a completely different scenario here, but it had the same result. I could have 10 sessions all run a 1-second query at once, and then 9 seconds of idleness. In my chart, because it's an average, it still comes out to be one average active session. I just want to show that different scenarios come out looking similar in the chart. In the next few slides, I'm going to talk about getting more information. So far, I've only been talking about idle and active, but just that simple idea of idle and active tells us a lot about the load on the database. But we can get more information. So in this example, we have that one user, they're idle, and then they're active, and then they're idle. But let's change that a little bit. What change am I going to make? I'm going to color code the type of activity. So here I have green representing CPU time, blue representing waiting for I/O, and orange representing waiting for some wait. So wait could be I'm waiting for a lock, I could be waiting for access to a buffer, waiting for access to a cache. So that first query comes in, spends all of its time on CPU, and returns a result set. The second query comes in, does a little bit of CPU, and then it finds it's missing some data in cache. So it executes some I/O calls down to disk to get that data, load it into cache, and run some more CPU, finishes its query, and returns its result set. The final third query, I come in and I do some CPU, then I run into a resource that I have to wait for to get access to. I get access to it, do some more CPU. Maybe I run into some other resource I need. I wait for it. Finally, I do some CPU, and I return the result set. Now, before where I just stacked activity, now we color code that stacking of activity. So I can see across the board I have a constant CPU load, constant CPU activity, with about half the time doing some I/O activity, and then once in a while waiting for some resources. So I'm starting to see what the personality is of the database. What's the load like on the database? It's coming through on the chart. Now remember, we collect data once a second. If we showed data once a second, the chart would be really noisy. So it's hard to read. And the second thing, if we take a long time span, that's going to be a lot of points to display, and it will slow down the display. So what we do is we average the data. As I mentioned before, each point in the default interface dashboard is 60 seconds. So it's the average load over 60 seconds. So here I'm getting to seeing what the load is on my database. I see it's rising and falling. But if somebody showed me this chart, my first question, really important question is that good or bad? I don't know. Is the system heavily loaded or is it lightly loaded? I don't know. Well, how do we answer that question? Well, it's a really important graphic artifact that we add to the dashboard, and that's this dashed line. It's called the max vCPU line, and it represents the number of vCPUs on the host the database is running on. And why is that important? Well, if I have two processes that want to run on the CPU and there's two vCPUs, then they can run in parallel, each on a different vCPU, and they're not really bothering each other. If I introduce a third process that wants to run on a CPU, then we're going to have to share those two vCPUs. The OS is going to have to time share. At any one slice in time, a process is going to be waiting for CPU. Somebody's waiting. That's an opportunity for optimization. And basically, we can look at this chart, and whenever the load goes above that max vCPU line, somebody's waiting. Now, they might be waiting for a CPU, or they might be waiting for something else, but I know as soon as the load goes above the line, somebody's waiting. And when that load goes way above the line, there's a bottleneck. And that's when I want to look into finding out why, what's happening. So now that we've got this max vCPU line and this metric, average active sessions, we can come up with a list of heuristics. Whenever average active sessions is less than 1, the database is not blocked. In order for the database to be blocked, I need at least one connection that's trying to do something that can't advance. They're constantly waiting. If the database is blocked, I probably even more than that, but I need at least one. So whenever AS is less than 1, I know the database is healthy. There's no blockage. The second point is really important. It's actually sort of cool. When AS is around 0, it means the database is idle. And I don't know how many of you are DBAs. How many people are DBAs here or have been DBAs? I remember one of my DBA jobs, it was like every second day, every third day, the application group would call me and be like, the database is blocked, the database is slow. And I'd be like, I'd look and the database is idle. And like, but what I was looking at, this is Oracle, I was looking at these StatsPack or AWR reports, and they're 30 pages long, and there's lots of stats. And in database, large enterprise relational databases, there's constant activity. Whether users are doing anything or not, the database is always managing stuff. So the counters are always moving. So how do you prove the database is idle? Well, if we look at the load chart and it's empty, it means nobody's waiting. It doesn't mean there aren't SQL. SQL might be really fast. They might be coming in and getting responded to really fast, and we don't catch them. But nobody's waiting for the database, so it's not the database's problem. The third point, whenever AS is less than the number of CPUs or vCPUs, there's CPU available on the machine. And this is specific to RDS, because in RDS, the only thing running on your host is the database. And so all the CPU is basically available to your database. And if your database isn't using it at all, then there's CPU available. Now, if you're on premises or something, you might have some other applications on the machine using the CPU, and you need to take that into account. Now, the next to last point, once the average active session starts to go past the number of vCPUs, then we get into bottleneck territory. And then last point, when average active sessions is way above the vCPU line, there is a bottleneck, and we want to investigate and find out why. So here's an example of an idle database. So when the users call up and say the database is slow or the database is blocked, and you have this graph, you can be like, no way, there's no load on the database. Nobody's waiting for the database. So you can prove really clearly and quickly it's not the database. Now, the load chart's also good for sizing. I mean, one other sort of thing that concerns me over time is like, did I pick the right instance type size? Well, when I come into the load chart and look at the CPU usage, if the CPU usage is, and by default with Performance Insights, you get a week of data. So I can scale out to a week, and I can see the whole load for the week. If the whole load for the week never goes above what I see in that chart, that machine's oversized for the database. Now, on the other hand, the bottom chart, my CPU load is way above my max vCPU line. That machine's undersized. I need a bigger machine. If I put that load on a bigger machine, it's going to run a lot faster. Okay, now how do we access Performance Insights? So I don't have any slides on this, but before we talk about accessing it, as I mentioned, when you create a database with a wizard and Performance Insights is available for that type of database, it'll be checked on by default. And that's all you have to do. You don't have to worry about installing anything. You don't have to worry about space or administration. And once it's on, there's two ways to access it. One, there's a Performance Insights menu. You can click on that, and it'll give you a list of all the databases that have Performance Insights enabled. And the other is in the instance listing, which is what I have here. In the instance listing, under the current activity column, which is on the far right, if Performance Insights is enabled, the metric unit there will be sessions. And next to that metric is a little rectangle. When the rectangle is empty, that means the database is idle. Once loads start to happen on that database, you'll see more and more blue. That rectangle will get filled up with blue. To the right-hand side of that rectangle, there's a little vertical red line. That's the CPU capacity of the box. Once we pass the CPU capacity of the box, there's a bottleneck. The more load there is, the bigger the bottleneck, the more red we'll see. That rectangle will start to fill in with red. So at the bottom of the slide, I've shown a bunch of red. There's some bottleneck on that database. So let's take an example. And we'll get to real use cases here. So here's an example, Aurora Postgres database. I look at the rectangle. I see a fair bit of red in it. It's click-through. I can just click on that. I just click on the session value on a current activity and go into the dashboard. So our first example will be a CPU bottleneck. So I click into that sessions, and then I'm brought into the Performance Insights dashboard. And remember, our sort of yardstick is that max vCPU line. So I see the value going above the max vCPU line. Over here, there's this big spike, some bottleneck happening there. Now, what kind of bottleneck is it? I can go and look at the legend. The legend tells me what the different colors mean. In this case, we have green. Green represents CPU. So I know during that bottleneck, there's CPU saturation. There's users waiting for CPU. They can't get it because there's not enough CPU available on the machine. Now, why is that happening? Where's that coming from? Then I look at the top SQL. And there's only one SQL that's really taking up all the CPU. Remember, CPU is green. If I look at the top SQL, there's only one that has a lot of green in it. It's that first SQL statement. It's actually a select from a function. So what I want to do is drill into that function and see if I can optimize that function. I mean, the other option would be putting the database on a larger instance class, but that's going to cost more money. If I can optimize this function, I might not need to do that. And one thing really cool is the interface is interactive. So far we've been looking at an hour timeline, the top SQL for that hour timeline, but the bottleneck wasn't that long. How do I make sure that what I'm looking at in top SQL is for that bottleneck? I can click and drag my mouse across the bottleneck, and we'll zoom into that time period. So you can see that it's highlighted in gray. I've clicked my mouse and dragged it across. Now when I release it, I'll go into that particular timeline. So here I can see the bottleneck, and I see clearly there's one SQL statement using all the CPU. I meant to mention, if you have questions, feel free to ask as we go along. I think there'll be time for a Q&A in the session, but happy to take questions as we go. I think there's a mic up front. Ask people to come up front to ask. Oh yeah, the mic's right there. So if you have questions, come up to the mic, raise your hand, and then come up to the mic. Okay, I'm going to go into the second use case. So this is a wait bottleneck. So here we have the dashboard, and I see a spike again, but it's a different color. So something else is happening. It's not CPU. I'm going to click and drag my mouse, and I'm going to zoom into that time period. So here I've zoomed in and just to that bottleneck. And I can see that almost all my load is this light orange color. If I go to the legend, I see that light orange is IO:XAC sync. Anybody know what that is? I don't expect users to know what these things are. Each database has its own wait events, and the names are typically obscure. So what we're doing, and this is an ongoing project, because there's thousands of wait events, and we're tackling the ones that we see the most, that are most common first. But we've added flyover help. I put my mouse over the name, and it'll pop up an explanation of what that wait event is and what kind of remediation action we can take. So just to summarize what's happening here, if we look at the text, basically it's saying that we're waiting for confirmations to writes to stable storage. And that typically happens when we do a commit. When I do a commit, I need a confirmation that that data is not just in memory, but written to stable storage. Where is it coming from? I look at the SQL. The first SQL I see there is this insert statement. It says insert into authors, 3 fields, and then 3 values. And what's going on here is we're doing lots of inserts. And I'm using a JDBC connection, and by default, it does an auto commit. So every single insert is getting committed. And that means every insert, every commit, I have to wait. And visually, we can see how much this slows us down. If we look at the bar for that first statement, that insert statement, to the left, there's a little bit of green. That's the CPU. That's when we're accomplishing work. All the rest of it is basically we're waiting. And I can sort of see the ratio that I can speed up this load, this batch job. So say CPU is maybe 1% of that bar, then potentially I could go 100 times faster. I can see visually how big an impact I can make on the database. And we'll go into live demo where we'll do that at the end. So far I've just been talking about the default layout of Performance Insights, but we can actually group the data by different dimensions. In the legend on the top right, it says by default slice by weights. And weights, I think, are the most powerful way to look at load on a database. But if we click on that little triangle that points downward, there'll be some other options. We can group by SQL, by host, by user. And similarly in the bottom, I show by default top SQL. Here I've clicked on hosts. So there's 4 values, weights, SQL, host, and user. So now I see the load by hosts. And typically hosts are application servers. And typically I have multiple application servers that balance the load across them. So I'd expect the load to be similar. And in this case, they're roughly the same. One application server says 1.23 average active sessions, and the other says 0.99. So they're both around 1. But I'm going to go ahead and click on the top, and I'm going to group the load and the timeline by SQL. So the load has stayed the same. It's the exact same load, the total load. What's changed is the grouping, the colors. Before we were grouping by weight type, by the weights that we're on. Now we're grouping by SQL. So I can see on the left-hand side, most of my loads by this teal blue and this orange SQL. But then where there's that spike, I see this lavender color. That means during the spike, some new SQL was run and was putting load on the system. Now, if I look at my application servers below, I also see something interesting. As we change the grouping on top, that'll change what the colors mean on the bar on the bottom. Now, the colors before used to be how much, basically the ratio of time spent in those weights. Now it's how much time that is coming from those SQL statements. And what I can see is that one application server runs a bunch of different SQL statements, and the other application server is running just one SQL statement, a different one. So that could represent, maybe I had a code rollout this morning, and the code made it to one application server, but didn't make it to the other. The work they're doing is different, and maybe the code didn't deploy correctly. So one thing that's really cool is this interface is the same across all the databases. Most of my career has been in Oracle, so I'm used to Oracle, and it can be hard to jump to another database and do performance tuning. But here, the interface for all these databases is exactly the same. The only thing that changes is the name of the wait events. So Performance Insights currently supports both versions of Aurora, Aurora MySQL and Aurora Postgres, as well as RDS MySQL, RDS Postgres, and RDS Oracle. RDS SQL Server is coming very soon, and then we'll be at MariaDB. So this, because the interface is the same, this allows a DBA who's comfortable on one platform to jump to another platform and do performance tuning. So the next few slides are just examples of the same load across different types of databases. So here's a load of 5 users on Aurora MySQL. And another ongoing project that we're working on is color coding similar weights across the different engines with the same color. So right now I see that a little bit of green, there's a little bit of CPU going on, and most of my time spent waiting for this light orange. That's the same light orange we saw before on Aurora Postgres. It means we're waiting for writes to stable storage. And I can see that visually without even knowing the name of the wait event. So here is the Aurora Postgres, the same workload. This is a simple workload of inserts, selects, updates, and deletes. I can see I'm using more CPU, and I can see that light orange. Again, I'm doing those waits for stable storage, and I see a little bit of red. Red's locking. So for some reason, this workload has a bit of a different characteristic on Postgres, Aurora Postgres, than it did on MySQL, and I can see that visually. Here's Oracle. Again, similar to the previous ones, I do a little bit of CPU, a lot of time spent for writes to stable storage, and then Oracle's a little different. Oracle has a background process that writes the data out to log files. That light blue is actually a background process wait. It's not a user wait. Here's RDS Postgres. Here we haven't yet color-coded the wait events. So even though it's the same load, the wait event colors are a little different. So soon we'll be adding the wait event colors so this will look like the other ones. But I can see here I'm using more CPU than, for example, this is RDS MySQL, using a little bit of CPU. And again, RDS MySQL hasn't been color-coded yet either. Okay, what's available? The engines released so far I've mentioned before, but here we have them in detail. We support all versions of Aurora Postgres. On Aurora MySQL, it's just Aurora MySQL 5.6, 1.17.3 and above. We're working on 5.7. We support RDS Postgres 10 and above only. We don't have any plans to support below 10. The main reason being is before 10, the wait events weren't sufficiently instrumented to be very rich, that are weak. In Postgres 10, we have a rich set of wait events that describe the workload quite well. For RDS MySQL, we do 5.6 and 5.7, but only the more recent versions. And then for RDS Oracle, we support all versions. And one thing cool with Oracle is Oracle, if you use Enterprise Manager, you can't use it on Standard Edition. Performance Insights works on any version of Oracle. Standard Edition, Enterprise, it doesn't matter. And you don't need any of the Oracle Performance Pack licenses. As far as functionality right now, we have what we've shown so far, the DB load chart and the top SQL, our top end table. And then we support these 4 dimensions, weights, users, host, and SQL. We have a public API. So if you have a custom dashboard and you want to add this data to a custom dashboard, you can leverage the API and put in a graphical widget in your dashboard. We have long-term retention. By default, the free tier, when you check it, is a 7-day rolling data window of performance history. If you want everything, you can subscribe to a pay-for option, and basically we'll save all your performance history. Right now, it's capped at 2 years, but really the goal is to save all your performance history, but it's a pay-for option. And then for alerting, the Performance Insights infrastructure doesn't have its own alerting, so what we do is we egress or we send some of the data to CloudWatch. Right now, when Performance Insight is enabled, we automatically send 3 metrics. We send the total DB load, and then we send the 2 components of DB load, which is DB load by CPU and DB load by non-CPU, i.e. how much time we're spending waiting for stuff. Now what's coming? So we're working on Aurora MySQL 5.7, working on RDS MariaDB, and RDS SQL Server. RDS SQL Server is the next one to go out, should be quite soon. And then functionality, we'll be enriching the functionality over the next year. So right now in the interface, when I see the top SQL, I can get the SQL text, but I don't have the execution plan. So we'll be adding the execution plan. Right now you could copy the SQL text and run your own execution plan, but that's a bit of friction. We want to make it as easy and frictionless as possible. We'll also be adding SQL stats. So when I look at the top SQL, I see the load by the SQL in the SQL statement, but I don't know how many times it's been executed. I don't know what its elapsed time is. So we'll be adding these per SQL statistics as well. And then finally, on the short-term roadmap is OS and DB statistics. So right now in the interface, we only show DB load, which by far is the most important thing to look at. But you might want to correlate DB load with something else. For example, maybe I have an OLTP database, and I know the transaction rate is pretty consistent. Maybe I want a graph of transactions above the load chart so I can correlate it. If DB load goes up and transactions go up, that might make sense. If DB load goes up and transactions go down, that might tell me that whatever that DB load is some bottleneck that's slowing my application down. So we'll be adding about 50 OS metrics and 50 DB metrics that you can customize the interface and add these graphs above the load chart and correlate them. So in summary, Amazon RDS Performance Insights, it all centers around DB load. DB load is measured in average active sessions. It clearly identifies the bottlenecks. It's easy, it's powerful. And with Top SQL, we can see where those bottlenecks are coming from, and that tells us where we want to apply our efforts. We encourage problem discovery in the interface, click and drag, zoom in on bottlenecks, look at data by different dimensions. And if you have any questions, we have a group, I'm probably the main person on it, but there's other developers and people at Amazon. RDSPI, you can send us questions, or if you have an enhancement request, I'd love to know what kind of information you'd like to see in the interface that's not there yet, so it can help set our priorities. Okay, now I'll do a little live demo. Okay, here's an idle database, and what I'm going to do is I'm going to run a load on it, and then we'll optimize that load. And you'll be able to see the reactivity. So here I'm going to kick off the load. I'm going to go into the 5-minute time frame, because the 5-minute time frame is going to show me my per second samples. So I just kicked off the load. I almost immediately see the load. That's end-to-end latency is amazingly low. We see our load coming on. What I'm doing here is I have 4 users. They're running 10,000 updates on 4 different tables. So I can see my 4 different update statements in each of the tables. I see the load coming on. We can see the database is what we call fairly heavily loaded. My load's all the way up to the max vCPU line. And what we're doing here with these updates is this is where auto commit is set on. That means every update is going to have to wait for a commit. And we can see, I don't really see any CPU usage right now, or very little. Which means that we're spending almost all of our time waiting and not getting work done, because we're waiting for the database to reply to us for these commits. So this takes about a minute. After it finishes, I'm going to sleep for 10 seconds, and then we're going to do the same workload with auto commit off. Basically, you can commit every 50 rows, every 100 rows, and basically we'll see what the impact of that is. So in the bottom left is the window running it. When it finishes, it'll show you the timings. One thing I want to point out is, so these wait event names are over here on the right. They're a bit long, so you don't see the whole name. And you can pass your mouse over it and see the full name. But one easy way to see all the wait events is to click on the weights in the top table. And if you look at the weights, and you sort of, again, these names are a bit obscure, but what I can see in the wait event names is they all have to do with either the bin log or logging. It's all about waiting for writes, log writes. Now we can see that the load ended. I'm now in my sleep period. I can see my first batch job finished. The time was 1 minute 49, it looks like. And so now we'll sleep 10 seconds, and then we're going to run the same 40,000 updates by 4 users. And it's finished. Boom. So earlier in the slideshow, I wanted to show you that load bar for that insert SQL statement. Almost all of it was wait, and if you got rid of it, you could potentially go 100 times faster. Here, I guess we only went 12 times faster, but still pretty impressive. Okay, a few quotes from our customers. Some of these people in the vendor hall, if you want to talk to them, Cloud Abilities there. They said, with Performance Insights, we have been able to quickly isolate slow and underperforming queries. Catalyze, not only has Performance Insights saved us a lot of time in diagnosing queries, it's also helped us lower costs. New innovations. One of the most valuable tools AWS provides for Aurora is Performance Insights. Our DBAs use this dashboard on a daily basis. Innova, before our diagnostic processes were laborious, with Performance Insights, we open one tool and quickly and easily see where we have problems. One quote that I don't have official sign off on is a customer said they just got support on Oracle. It's like, it's Christmas come early. Okay, last part of this presentation. This is a sort of fun part. What we did is we did a collaboration with a consulting company called Slalom, which has a booth that you can go visit and go interact with this demo, booth 1438. But what we did is we hooked up Alexa to Performance Insights. So now you can, in this demo, you can talk to Alexa and ask performance questions about Performance Insights. So I can imagine some manager having this on his desk and saying, how's my fleet doing today? So the next slide is going to be a video.
Alexa, open Performance Insights.
Welcome to Performance Insights. How can I help you?
How are the databases doing in Ohio?
Performance Insights reported no issues in your databases in Ohio.
Check the database performance in Northern California for the past 2 days.
On Wednesday, November 14th, the average active sessions on AMS 5.6 was 8.7, more than the allocated 4 vCPUs. What would you like to know about this incident?
What's causing the load?
94.4% of the load on AMS 5.6 was coming from CPU. Load from the other wait types is low.
Who was responsible for the load?
User KYLELF is causing 91.9% of the load on AMS 5.6. Would you like to notify the user?
Yes.
Would you like me to email or send the user a text message?
Email him.
Email has been sent.
Stop.
Goodbye.
So I sort of for fun, but that's a real demo, and it's real information. Now, the person doing the demo is just interacting with Alexa, but on their desktop they had Performance Insights. Like, Alexa's not driving the UI, we're just talking to Alexa. But so you could sort of visually see what Alexa's talking about, we had the UI. The UI was in Northern Virginia. He first asked about Ohio. The database in Ohio were running fine, but that one database that we had visually shown there was the database with problems. It showed the problem and it showed the user, and you could see how Alexa was responding to it. So it's a lot of fun. So now we have some time for Q&A if you want. Again, there's a microphone here. Please come up and ask your questions at the microphone. And again, if you want to ask me questions offline, you can reach me at rdspi@amazon.com.
1, 2, there it is. Thanks, Kyle, for this session. I have a question about the sampling. I mean, I understand what the sampling does for you, but when you have very many short queries, sometimes it's an application logic thing that you need to do because there's chatter or because, and they're actually, you wouldn't necessarily see the load, but it could be an example of why it would be slow, where the proper remediation would be to go back to the application and change that to be maybe more coarse-grained work. but those things wouldn't show up, right? And I mean, would they show up on an average, or I mean, I guess they'd be scattered enough. I guess my question is, how do you see that as a potential risk of the sampling strategy?
Okay, let me try to phrase that, what I heard. Some of the interactions with the database are a lot of chatter. When I hear a lot of chatter, that means to me that there's a lot of back and forth means latency. Like the example that we had with the commits, that's chatter. I'm waiting for each commit. By batching it, I get rid of all that chatter. I just have one I reduce my number of communications and responses. And this is something I've been thinking about how to visualize this. But the weights, those chatter weights, was actually in the demo I gave is pretty easy because there wasn't any latency. My load is running really close to my database. There's no latency. If I move my load, those commits farther away from my database, that load chart, as we saw, it was full. I had 4 users and it was 4 active sessions. It was full. If I move my driving, say across the country and ran the same load, that load chart would be more or less empty. Now, what that means to me is there's not a problem in the database. The problem is the network. And how to expose that in Performance Insights is something I'm thinking about how to tackle. But yeah, latency that happens outside the database, is basically comes across as a lower load in the database. I don't know if that answers your question. The only way I know to do that as far as like somebody who's taking care of the database is if I run a batch job and there's no sleep and it's all SQL, then there better be, for my per session, there better be 1 active session in the database. And if there's not, that means there's latency. But that means I have to have some knowledge of what batch job or what load I'm running and then see the load chart. And they better correspond, and if they don't, that represents latency. Now I'm trying to think of programmatic ways to expose that to the user, but we haven't done that yet.
Hi. Hopefully I can ask 2 questions. First is, do you have anything in terms of baselining where you could compare, let's say, the performance maybe over what a week looks like or a day, and does it always look the same on Monday or Tuesday, et cetera? And then the second question was just the new features you said that are coming soon and having MariaDB, are those, how soon? Do you have any idea?
Okay, so first one, it's compare periods and then when are the new features coming out. The compare periods, right now we have a week of rolling data, so you can manually look at a time period and then look at a time period. If you need more than a week, there's an option to save all your data. So you could look at, end of quarter, end of year versus end of year. That's all manual. You do it you just visually do it right now. On something that I plan to do though is have a automated comparison. You select a time period and then another time period, and then it would put out a report comparing the two. That is something that I plan to have the team do. Yes, and I would like to do it this year, but we can't talk about delivered dates.
Thank you.
Oh, the other part was MariaDB and SQL Server. SQL Server I know is really close because it's basically, I'm using it, looks perfect, the code's done, it's ready to deploy, so I'm just waiting for deployment to the fleet. MariaDB should be straightforward. I haven't gotten a commitment from the team, but I would think it should come out within a quarter, but again, we can't talk about, it should be very soon, within a quarter time period.
Hi, Kyle. So you mentioned reports a little bit, but I didn't notice it on the feature list coming out. So what's the recommendation for getting developers access to a production system? Typically we use Insights in our QA and performance environments, but we don't have our engineers look at production. So what's the recommended way to do that? Is it to have like a read-only view into the production account, or use maybe the API to get data out? How would you recommend to do that? Yeah.
So the question as I hear it is, how do you give developers access to this? And that's a great question because developers are usually like primary Java or primary Python or something, but they have to write SQL as part of their job, but they often don't have any idea what that does to the database. And if we can give them access and they can run their code, they can see visually what the impact of the code is. So it's a great thing to give developers. The main friction I find to giving developers access is mostly political, and we'll go into some other aspects of it. But you can create a read-only access and give them PI access. They can't change anything in your system and they can see the data. Now, that could have some drawbacks because maybe you don't want them to see everything. Maybe maybe there's visible predicate filters that might be important, credit card numbers or something. Another thing that we are talking about implementing is multiple levels of access. Right now, you see everything or you don't see anything with performance insights. But what we could do is, and this is sort of what we haven't, like internally at Amazon, I can see your dashboard, but I can't see what you're doing. I see the load, I can't see anything. I can't see your usernames, I can't see your machine IPs, I can't see the text of your SQL because it could all be sensitive. So I can see the load on your machine. So we could create a user access like that, but you probably want something in between. So we're talking about other things like stripping all any hard-coded values, stripping them from the SQL and having that be a level. So we're talking about implementing multiple levels of access to PI. But again, it's going to come down to political things. I mean, you still have to have a company that's going to allow a user to log in. And if that's not an option, then you'll have to use the API and create your own dashboards.
Okay.
Is that?
Yeah, thanks. Good.
Yeah, I was just curious about possible features regarding memory usage per connection and how that works, because that's kind of like a black box in MySQL. So do you have any plans to add that?
So the question is, are we going to expose memory?
Yes.
And what databases do you use?
MySQL, Postgres, pretty much SQL Server.
Okay. Yeah, right now, the first thing's coming is the OS metrics, and those should be coming very soon. So you'll have like, you'll have typical operating system OS metrics around memory. And that's a good starting place. That could show us if there's some sort of memory pressure on the system. What I'm more interested in is why. Who's taking up that memory? And that's a longer term project. For example, in Aurora, in Postgres, as far as I know, there's no real memory. Postgres doesn't expose memory usage by users. But we're talking to the Aurora Postgres team. With the Aurora Postgres team, the cool thing is we can change the kernel. So we're talking about exposing that through things that PI can pick up and then show you per connection, how much is it using for the cursor? How much is it using for temp? How much is it using for row caching? So I would expect that to happen at some point. It's something I desire highly, and your feedback is useful because that helps me set the priority on it.
Excellent. Thank you.
Yeah, just one question about how have you worked a lot with integrating it with the AWS CLI and optimizing it for that? Because I love using it. And I see you get a lot of information about like vCPUs on EC2 instances, but is all the data available via the AWS CLI?
So I didn't get the AWS CLI?
Like just the client, the
CLI?
command line. Yeah, the CLI.
Oh, yeah. So you can leverage the API through the CLI. So you can get all the data through the CLI right now. Yeah, and it's all there. You can have access to it for whatever your storage retention is. So the free tier is 7 days. So you can go use the CLI and look at via the CLI all the data for that week.
All right,
and you can use that to hook into other monitoring products or your own dashboards.
Yeah. Save the data long term.
And you could use, right now, if you wanted to offload the data, you could use the CLI API to offload the data into your own databases and do your own analytics on it.
One of the limitations that I've seen playing with it up to now is that the size of query that's exposed within IPM is that limitation kind of hard set by, we're using MySQL at the moment.
Yeah, so the question, okay. So right now there's a limitation on the SQL text, and it's 500 characters. And yes, that's a problem for a lot of queries. So we are implementing what's called large text. It's another project. The project's been implemented on Aurora Postgres. Right now, I think the limitation is 10K, but it'll become unlimited soon. And we'll be rolling out that feature soon across, because now that we've done it on one platform, we'll be rolling out across the other platforms. So that limitation should be taken off very soon. So you can see as much as megabytes if you wanted, yeah.
Hi, hello. How is this going to play with Aurora serverless? Like, ultimately, I need to be able to tell the difference between like a serious load that I need to increase resources versus like really crappy SQL that I don't want to increase resources, I want to fix this problem.
Yeah, so the question is, how is this going to work with serverless? So right now we don't not support on serverless. Serverless presents us some problems. If you delete a database, we delete the performance insights data. And serverless is, instances are coming and going. So we're going to have to implement a way of keeping data after the instance is gone. And it is something we're working on. But that way, I imagine there'd be some sort of option in serverless, like you keep all my serverless data even after you've gotten rid of the instances, so I can go back and look at it. So that's on the agenda for this year.
Okay, well, but even if it's running, say I have like a minimal load, so I'm never idle, you know, like it seems like that you could run into the problem where the graph always looks awesome, right? Because it just scales up and gives you more resources, and so you never see the problem because they're trivialized by the fact that you just keep throwing resources at it. And how will we be able to tell, like, you know, like that there really is a problem there and that you've just kind of over-resourced it? Like it just seems like it's going to get lost. Really?
So what I heard is how do you tell that in a situation where you've over-resourced, how do you tell that there still is a problem?
Yeah.
Well, that's sort of the whole point of the interface. I mean, if I'm waiting for stuff, okay, resourcing is just affecting CPU. So serverless might spin up a big machine, give me lots of CPU, but then I'm spending all my time waiting for something, some resource. It could be I/O, locks, buffers, and that's what the interface shows. So if we have it on serverless, you'll be able to see if you're waiting for something other than CPU very clearly.
All right, cool. Thank you.
Yeah.
In one of your slides, and maybe I missed it, you were talking about the exact sync wait.
Oh yeah, I/O XAT sync.
We've seen that a lot on some of our issues. So you're saying that is because we're constantly doing a commit on our transactions?
It could be a commit, most likely commit, could also be a rollback, but yeah.
So how would one go about alleviating that issue?
You have to batch it. So if you're doing lots of single row operations, the idea would be able to batch them into multi-row, like 50 rows and then commit. And that will basically eliminate most of that wait.
Wow.
Feel free to write, if you have some example cases, feel free to write us at that RDSPI.
Well, one thing I've noticed about PostgreSQL that I've not noted in recently, which was a really cool feature of Oracle, is being able to do batch like fetches.
Yeah,
you know,
for bulk collect, yeah.
Yeah. Postgres doesn't offer that, does it?
You know, I'm not sure. It does do, for as far as collections, I don't know. I mean, collections aren't going to run into that IO-XAT sync. What's going to run into those are some sort of manipulation, insert, update, delete.
Right.
For those, you can do bulks. I mean, I can do a multi-row insert. I have two options. One, I can do a bunch of single inserts and then commit with auto commit off, or I can do a multi-row insert in a single statement, which will be even faster. Now, I'm not a Postgres expert. I don't know if there is a bulk. On top of that, Oracle also has these bulk inserts,
right,
which are even faster. I mean, Oracle, man, you can stuff stuff in and.
Yep. I was curious because we're kind of in a situation where we'd have to rewrite the app, I think, to solve some of these problems. But we're seeing that used a lot. It was like, okay, what's the easy fix on that?
Yeah, for something like that, you've got to rewrite your app, the way the app's interacting with the database. There's no parameter that will change it in the database. Yeah, shucks.
Thanks.
Just a clarification. So you mentioned the I/O and CPU types, and if we've got like a heavy read operations and all of it is CPU, does that mean it's going to the cache only and it's never going to disk? And that's just always.
So what I heard is if I'm running a heavy read load, but I look at the load chart and all I see is green CPU, does that mean I'm getting it from cache? Yeah, most likely. It means you're not spending any time waiting for reads from I/O from the disk.
Okay.
So.
And then you mentioned using this for sizing. Is there any best practices for using the vCPU for sizing your?
I mean, right now it's all manual. Like I have to visually look at the chart or write a program that does analysis. You know, most likely just the way things are going, there'll be a point where there'll be an advisor that'll say, look, we looked at your load for the past week or the past year, and you never used more than X%. That, that's a matter of time. That'll come. But for right now, you have to visually look at it or write your own little programs.
Right. Thank you.
When Performance Insights is doing the sampling, does it measure or like record like deadlocks, like table locks or row level locks, and like which operation is actually holding the lock and which ones are waiting? And
Right. So right now, the question is, when there's locking, do we collect, other information like who's the blocker, what are they locking on? Right now, we just basically show who's waiting for locks and what queries they're running. On the agenda is to do a heavy lock analysis. So that would show you who's blocking you, what were they doing, what were you doing, what was the row. That's something we're working towards, a deeper lock analysis.
thanks.
I think we're out of time. So thank you for coming today. I appreciate your time and look forward to feedback on the feature.